Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Data Science, the Next Rockstar. Our guest speaker today is Mr. Dr. Dakshinamurthy V. Koluru, President, International School of Engineering. Dr. Dakshinamurthy holds a PhD and MS degrees from Carnegie Mellon University and Bachelor's of Engineering from the NIT, Trichy, India. He is responsible for research and development, product management, developing consultative solutions, program management, and strategy formulation. During his 17 years of experience as a scientist and an entrepreneur, he has applied his strengths in logical thinking, math and science to solve industrial and societal problems, designing solutions from fundamentals, identifying, training, and motivating high-quality individuals, and articulating the findings in a lucid manner to all the stakeholders. He has applied these skills in such diverse areas such as the Web 2.0 software development, mathematical modeling of capital markets, e-learning programs for rural students, intercontinental ballistic missile design, etc. Dr. Murthy has filed for 4 patents, published over a dozen international articles, and presented in over 50 international seminars and conferences. So without further delay, I introduce you all to our guest speaker, Dr. Murthy. Over to you, Dr. Murthy.
Thank you very much, Mohini. Hello, everybody. It's indeed a pleasure to deliver this workshop seminar to all of you. As my screen shows, just one. There is somewhere. As my screen shows, today I will be talking about data sciences. Before I start discussing about data sciences in general, I just wanted to talk about or introduce you to various terms that are used by people from various domains while referring to data sciences. Data sciences nowadays is a term that is made popular by EMC Square, which is into storage and related areas, but their primary emphasis in the past few years from the data sciences has been integrating analytics, Hadoop kind of technologies. Around 4 or 5 years back, Google, Facebook, and Yahoo started doing a lot of work in the similar field. However, if you look at their literature, they most commonly refer to the same field by the name big data. And IBM, for the past 4 or 5 years, has been pushing the domain term business analytics and optimization, where they have made substantial investments, built labs, and promoting services and consulting and education in the area. They call it business analytics and optimization. What I wanted to start with is more or less all these 3 terms refer to similar problems that are faced in the industry. More or less they all refer to similar domains. If you go to a university, traditionally the same domain is referred to as machine learning in the data mining in computer science departments, and analytics in the business and management departments. So this term has a lot of different nomenclatures: data sciences, big data, business analytics optimization, machine learning, data mining, analytics. And recently I found that statisticians are calling it modern applied statistics. So there's a lot of excitement. Experts from various domains are working on this field, and multiple names are being given. However, broadly they all belong to this fundamental area called data science, which is what I am going to use for our rest of the webinar today. I'm moving to the next slide. I'm sure you all have seen a lot of examples of very large data. I am not going to spend a lot of time marveling about the increased amount of data being produced. I'm sure you have seen them, but I will present just two of my most favorite examples. First, I want to bring your notice to the table that's at the bottom of the slide, where it talks about, if you compare the digital information with the physical information that you find in a book, a byte is equivalent to a character, a kilobyte is equivalent to a page, a megabyte to a large book of 1,000 pages. Gigabyte is a small library of 1,000 books. Terabyte is 1,000,000 books. Petabyte is 1,000 of the largest libraries of 1,000,000 books. Exabyte is 1,000,000 such large libraries, and zettabyte is billion such large libraries. And an estimate is that every year we are producing 1.2 zettabytes of data, and that's doubling every 2.5 years. So that's a tremendous amount of information. Other favorite example of mine is Apple iPad, which is considered to be the sleekest and thinnest equipment for storing data. It carries around 64 gigabytes of data. If you were to stack Apple iPads as a pyramid, you will create a pyramid that is 25 times taller than Mount Everest to store the amount of data that's being generated every year. So one message that I want you to take is that all these companies are so excited recently about this field because there is so much of data being created. Every year the data created is equal more than the amount of data created in the rest of the history of mankind put together. So that is why IBM calls it big data optimization, EMC calls it data sciences, Google calls it big data, universities are working on machine learning because this is a pressing problem. Now, from a very, very fundamental perspective, what the IT has done, IT enablement has done to the organization is to create this large sea of data. Every organization now has this humongous amount of data. However, a 5,000 feet view will not do anything more than that marveling and that getting impressed. It will not give any further insights into this sea of data. Only when one dives deep, one realizes that there is a new ecosystem there, there's a new wisdom there, there is a life there that has not been identified by the organizations. And data science is that field which enables people to take the deep dive into data to enhance their understanding of the data that is being stored by their business or that's being generated and stored by their businesses. So what we will look at in the next 1 hour or the 55 minutes is essentially what exactly people do to dive deep and what are the challenges they face and what are the precautions that one could take while diving deep into the sea of data that they have. Any data science work, almost any real world data science work starts with a lot of messy data. Messy here is the key word. People do only in the college university homeworks you get data that is well cleaned up, structured and organized, but in most real world cases there will be a lot of missing data, there will be a lot of inconsistent data, there will be a lot of noise in the data, You need to normalize the data to bring them into from different scales into similar scale. A typical data science project, a real-world data science project, people should spend anywhere between 50 to 60% of their time pre-processing the data. This is mostly overlooked by many organizations while they are trying to start an analytics project or a data science project or bid for a data science project. Very often, most of the projects, you need to account for at least 50% of your time in understanding, pre-processing, and cleaning the data. And in fact, it's not uncommon to have a data science project whose end objective itself is to clean the data. We did work on some projects where that was all that the client wanted. I'll give you this messy data, just clean it up and give me the cleaner data. But let's say once you have cleaned the data, you have this nice pre-processed database on which you have to do a data science project. First thing that I want to talk about is what are the various things that data scientists are expected to do. The first and foremost task of a data scientist in